Our next lesson is over Chapter 5, Section 5, using similar figures. So in this lesson, we're using the proportional reasoning, setting up proportions and solving them that we did in 5.4, but we're adding in geometry. So here's a little vocabulary for you first of all. So if you could, at the top of your notes, you need to have 5-5, using similar figures, because that's the title of our unit, our section. And then go ahead and copy these down. If you want to pause this so you can copy them down, you can. So we'll be using congruent a lot in geometry. It basically means equal. Usually when you say things are equal, you're talking about numbers. 4 is equal to 4. 2 plus 2 is equal to 4. We're talking about numbers. When we get into shapes, then we start saying congruent. That it's kind of the same idea as equal. They are the same. But since they're shapes, there's not a value to it. So that's why we use the different word. But I kind of use them interchangeably. So congruent figures just mean that two shapes are exactly the same. They have the same size and the same shape. In this lesson, we're going to be talking about similar figures, though, which are a little bit different. So similar figures are similar to each other. So they're kind of the same, but not exactly. So we're looking at if you would blow something up. So think about having a picture and making it larger. So with similar figures, our corresponding angles, which in two figures it's the matching angles. This will make a little more sense once we start looking at them. The corresponding angles are congruent, or the matching angles are equal. And then the lengths of the corresponding sides form equivalent ratios, which means it's proportional. So here's where our proportions come in. So what we're looking at is if I had a triangle like this, and sorry for my meager drawing abilities, if I would enlarge that, blow it up, it would be the same shape but a different size. Now what we were talking about with the angles are congruent. This angle is the same as this angle. They measure the same. This angle matches this angle. This angle matches this angle. Okay? Then with our sides being proportional, let's say that these are 2, 3, and 4 centimeters, inches, whatever, units. If I'm enlarging it, then however much I enlarge this side, this will be enlarged the same amount. So if I'm doubling this, it will go to 4, which means this side will be doubled as well. So this will be 6, this will be 8. Okay? We'll get into this a little bit more in 8th grade when we do a little bit more geometry, but I just wanted you to be aware of this. So for today, you're going to be having problems like this. I hope you can see it. It's a little dark. So we have one triangle who has a side of 24, a side of 15, and this angle is 31. This triangle, this side is 20, this side is 24, and this measure is 121, that angle. And then down here it's telling me that the two triangles are similar. Just this little squiggly line means similar. Okay? So what we're trying to do, so now I have some room to write, is I want to find every other angle measure and every other side measure from these two triangles. So let's look at the angles, because not a lot changes there. So we said that corresponding angles are congruent. So this angle corresponds to this angle because they're both that same angle. They're matching. Okay? So since this one's 31 degrees, that means this angle, this little angle is going to be 31 degrees. This angle is 121 degrees, so its matching angle up here will be 121 degrees. Now, this is a little bit of geometry that we haven't done so far. We have 3 angles in a triangle. Every triangle, the sum of all 3 angles is 180 degrees. So if you would take 180, subtract 31, subtract 121, that would leave you, I'm running out of room, with 28 degrees. So this angle is 28 degrees. Sorry, that's a little above the line. That angle measures 28 degrees because these as well are corresponding angles. Alright, so now let's look at our sides. So we said that our sides are proportional. So that means we have to do proportions. I'm going to redraw these triangles real quick. This is 24, 15, very crude sketches here, 24, 20. So if we look, we have two sides that are matching. Okay, these are corresponding sides because they're both in that same position, right? So that's going to be my one rate that is constant, okay? So that's telling me how much I enlarged this shape to get this one. So in order to find this side, I need to look at its corresponding side in this triangle. Well, for this line, it would be this line, which is 24. 24 was with the 15. 15's in the top. So I need to put this 24 up here. And I'm finding, I'll call that x. Okay, so I'm going to find x. So 15 over 20 equals 24 over x. Alright, so solving proportions, I have 15 times x, or 15x, equals 20 times 24, which would be 480. Dividing both sides by 15 tells me that x is equal to 32. So that means this side, or this side in my original shape, is 32 units long. Now, let's find this one. I already used x, so I'll use y. I'm going to stick with 15 over 20, since that was originally given. So, I'm trying to find y. Y is in with 15. 15 was on the top, so I have to put y in the top. Then, I use 20 in the bottom. Okay, so I'm looking at this triangle for my other bottom. What side corresponds to y? Is this 24. So 15 over 20 equals y over 24. So using proportions, 15 times 24 is 360 equals 20y. Dividing both sides by 20 gives you that y is equal to 18. So that means this other side is 18. Okay? So now, let me tear off my little cheat sheet here. Alright, here's our next triangle, or here's our next image. So I would like you to go ahead and copy this down, and then we're going to work on it together. If you need more time to copy it down, go ahead and hit pause. Otherwise, we're going to move on. So I have, So it says the triangles are similar, and that's 4 degrees. I want to find x and y. Okay? Sorry you can't see these. Sorry about that. So, looking up here, where should we even start? So x is a side, oh that's y, not 4, sorry. Here's y. Y is, I'm going to change to white on here. So this is y. So y is an angle measure. Okay? So let's look at our other angle measures, because those are usually the easiest. Since everything's congruent, we don't have to do a lot of manipulation. So if we look in our other triangle, we know that this angle is 44 degrees, this angle is 134 degrees. So which angle corresponds to y? Do we know it? Or is it the one we don't know? It's the 44. So we can say that y is equal to 44 degrees. Okay, because those are corresponding angles, so they're congruent. So now let's look at our sides. I have this side is 18, this side is x. Over here, I know that this side is 24, this side is 16. So I'd like you to go ahead and see if you can figure out what we're going to do. How are we even going to find x? What do we do with our sides? Proportions. So we need to set up a proportion. What would it be? Now, there's a couple different ways you could set up this proportion. I always look at, okay, I'm trying to find x, so I'm going to start with x. Okay? Well, in this triangle, I also know 18. So I have the two sides from one triangle in both of the numerators, or in the top of both of these rates. Okay? So now we need to look in this triangle to figure out which are our corresponding sides. So with x, what matches with x? 16. So underneath x, I'm going to put 16. So then what matches with 18? 24. So I'm going to put 24 underneath there. So working this out, solving this proportion, I get that 24x is equal to 16 times 18, which is 288. Dividing both sides by 24, I get that x is equal to 12. So if we look, this triangle is smaller than this one, so 12 should be smaller than 16, so that should work.